Okay, so this is going to be a lesson on how to deal with limits when you have graphs to look at or graphs to draw. So let's get started. First one. Explain in your own words what is meant by the equation. Is it possible for the statement to be true and yet f of 2 equals 3? Explain. Kind of redundant. Anyways, so we have the limit as x approaches 2 of f of x equals 5. So we need to explain in our own words what is meant by this equation. So in order to do that, we need to know what the heck a limit is. A limit is what you expect to get and not what you actually get. So in my own words, I would say that as we approach 2 on the x, comma, we expect to get 5 for f of x. It looks like we're heading that way, right? Now, it's not always the case that we actually get 5. It just looks like we're veering towards it. And so it says, is it possible for the statement to be true and yet f of 2 equals 3? Yes, right? It is. And let's give an example. So you have a little picture, right? And the x value we care about is 2, correct? And so we're going to look at a function that looks like, as it goes towards 2, it looks like it's hitting 5. So we have a 5 on the x value. And say we're approaching and we're approaching, we're going up and we go up and we get, okay, it looks like we're going to hit 5. And then it's continuous, so it looks the same from the other direction, correct? They both look like they're going towards 5. However, our actual value here is going to be at 3, right? So this is a function. It's got a little gap, a little hole right here, and it's probably piecewise in construction. But as we approach it from either side, it looks like we're going to get 5. So the limit is, in fact, correctly equal to 5. However, the value f of 2 is actually equal to 3. So we have this question. Use the given graph of f to state the value of each quantity, if it exists. If it does not exist, explain why. And we're given this graph here. Okay. So just looking at the graph real quick, we see there's a little curve, and then there's a jump downwards, and it goes up normal curve, and then there's a little hole at 4. And let's see what they ask for. The limit as x approaches 2 from the left, that little negative sign meaning from the left, of f of x. And so we're going to say, okay, what the heck is that? And so we follow along, and let's say we're approaching this point 2 right here, and we're coming from the left. So as we approach 2 from the left, meaning we're moving to the right, it looks like we're going to hit 3. So we're going to say it's actually equal to 3. Then we say, okay, well, now we have the limit as x approaches 2 from the right of f of x. This little plus at the top of the 2 means it's from the right. And so we go along, and we say, okay, we're looking at that same 2, still looking at that 2 value, except we're coming at it from a different side. And as we approach along this curve from the right, it looks like that the height, the f of x value, is going to be equal to 1. Okay? And then they say, okay, what's the overall limit as x approaches 2 of f of x? Notice there's no left or right here anymore. It's just, what's the limit? What do you expect to get there? And that only exists if we have something cohesive. So when we're going from the left, it looks like we're going to hit up at 3. And we come from the right, it looks like we're going to hit down at 1. And so there's no consensus, there's no meeting point. It looks different on both sides, and so we say does not exist, period. Okay. And then, next question. It says, what's actual f of 2? Well, the actual f of 2 value is going to be the point that's filled in. See that point? It's actually filled in, whereas down here at 1, it's empty. And so I'm going to say that's equal to, in fact, 3. So it's equal to that earlier limit because it's got that filled in hole. Next, they ask, what's the limit as x approaches 4 of f of x? So now we're looking over here at this 4, right? And we say, okay, well, there's an empty hole there, so there's no actual value. But if we come from the left, it looks like it's going to hit 4 in height. And if we come from the right, it looks like it's going to hit that same 4. So overall, because it meets, because it looks like it's going from both sides to the same place, that place it's going towards is in fact 4. And the limit itself is 4, even though there's an empty hole there. Now, in terms of the actual value, I don't see an actual value, right? There is no value. And so I say it does not exist because there's no input there. Maybe it's somewhere else on the chart that we can't see and we put that, but from our information, There is none. There is no value at 4. And that is that. Next question here. So we have, for the function a, whose graph is shown, state the following. And we have this weird squiggly looking graph with some asymptotes. And it's asking about limits. So it says, what's the limit as x approaches -3 of a of x? So a of x is our function in pink, and then we're looking at the value -3 on the graph, right? So we need to say, what's going on? What does it look like we're going to hit as we move along the graph from either side? And so as we come at it from the left, we're moving up and up and up this graph, right? And so as we keep going towards that -3, we just keep going up. So it looks like it's going upwards towards infinity, positive infinity. And it turns out, if we look from the right as well, as we're moving up and up and up, it looks like we're going towards infinity. So because both sides look like they're approaching infinity, then we're going to say the limit as x approaches -3 for the graph is in fact equal to infinity. For the next question, it says we have the limit as x approaches 2 from the right of a of x. So we're over here and we're looking at 2, and we're saying, okay, what about from the right? Well, we need to look over to the right and we say, okay, we're moving up, moving up, moving up. We're coming from the right, moving up and up and up. And it looks like, once again, we have infinity. Then it says, what about from the left? The limit as x approaches 2 from the left. Getting the negative sign meaning from the left. Well, this time, it looks like as we move from the left, it's going downwards, downwards, downwards. So as we're approaching 2 from the left, we're moving along the graph as shown. It looks like we're going down towards negative infinity. And then, finally, it says, what's the limit as x approaches -1 of a of x? So we have to go to the -1 and see what's happening there. So we go to -1 right here and say, okay, well, I see that it's going downwards, downwards, downwards from the left, downwards, downwards, downwards from the right, and from both sides, because they're both doing the same thing, it looks like they're both going down towards negative infinity. So next we have a question, and instead of being given a graph, we have a function. And they ask us to sketch the graph of the function and use it to determine the values of a for which the limit exists. So that means we have to sketch a graph, obviously, and then we have to decide where is something going wrong and where is everything fine and normal like usual. Where is there some kind of discontinuity? Where is there something where both sides aren't exactly matching up and something weird is happening? So first we sketch the graph and see what happens. So to start, we say, okay, 1 plus x. So that would normally be, okay, well, the y-intercept is 1, right? And we say, okay, there's a slope of up 1, right 1, up 1, right 1, because the slope is 1. Well, we also know that this only is true when x is less than -1. So we have to look at this -1 and say, okay, well, we can't draw anything to the right of that -1 because this doesn't affect that. So normally it'd be plus up 1, right 1. It could also go down 1, left 1, right? And so it would actually start here, and it would start with an open bracket because of this open inequality. So we draw that open circle to match that inequality sign. And we say, okay, well, we'll continue going, down 1, left 1, down 1, left 1. And we'll go down like that forever. Next, we look at this parabola. It's x squared, right? And so this is going to go from -1 up to 1. Notice the -1 is inclusive and the 1 is non-inclusive. So we say, okay, this is our 1, right? And we know how to draw a parabola. This vertex starts at 0, 0, right? It's going to go up like that, right? And it's going to go up like that. Okay, now we need to decide, is this an open circle or a closed circle? Well, this was a strict inequality, and so we have a closed circle right here. And over here it's an open, and so we draw our open circle, because there's no equal sign there. Right? And so we have our parabola portion. And again, we only draw it from these portions. We're not going to go up forever to the left or up forever to the right, because that's not a part of what our graph looks like. Next, we can draw this final line, which is actually, so the y-intercept is at 2, and the slope is -1. So we'd actually go down 1, right 1. And if you notice, that matches right here. So it actually fills in that point. Yeah? And we'll actually go down 1, right 1, and we'll do that forever. So this is actually matching together, and they are cohesive. They connect, which is nice. So now that we have our graph, we actually have the tools we need to answer the second part of the question, which is determine the values of a for which the limit exists. So in order to answer these, you kind of want to think, where is something going wrong? And say it's okay everywhere except for those spots. And so the only place I see something going wrong is right here at -1, right? Why? Because as we approach from the left, we see, okay, well, it's going towards 0, right? It looks like we're going to hit that 0. However, as we approach from the right, it looks like we're going up to that 1. And so we'd say at -1, there's some kind of discontinuity. It's not working out. And so we'd say something like all real numbers except a equals -1. And notice that isn't true over here for this, right? For this portion at 1, even though it's two kind of different portions of this piecewise function we're given, it connects. This is all technically just one function, even though it's been colored differently for effect. This is connected at this point. This is continuous right here. It works out. Because as you come from the left, as you're moving up, you're going up towards this, it looks like you're going to hit -1. And as you come from the right, it looks like you can hit that same -1. So we say the limit, as x approaches 1 over all of this +1. And so there's a limit there, and so it counts. And then our final answer is going to be all real numbers except a equals -1. And you could also use some kind of like union set notation of like -infinity, comma, -1, union, -1, comma 1. Union 1 comma infinity, and split it up like that. But that really depends on what your teacher wants from you. Most teachers are fine with this. Some teachers want you to have the practice of writing that notation, understanding it. You might have to write it like that. That's an example of when you're given a function, a piecewise function, and you have to draw it. It's not drawn for you, and then you have to decide what to do with it in terms of the limit. So another kind of question you can be given is when you're asked to sketch a function based on given limit properties. So let's just do an example. So we're given some information about what our function should look like. We know that the limit as x approaches 0 from the left should be -1. The limit of 0 from the right should be 2. And the actual value of f of x at 0 should be 1. So those are the restrictions, and then we have complete freedom to draw it however we want other than that. So let's get a simple graph going, right? And so we'll say, okay, it's easiest to focus on one thing at a time. So looking at this first portion, it says, okay, well, we're looking at 0, right? So we're looking at this 0 value, and we're going from the left. And so let's say we're coming from down here, right? We're doing some weird squiggly stuff, and we're supposed to hit -1, right? We're supposed to hit that -1, or at least approach it, right? So we're approaching, and we've approached it, okay? And then it says from the right, it should look like it's going to hit 2. So we go up here to 2. And we say, okay, maybe we have some kind of squiggly thing going from up here, right? You can squiggle up, and it looks like it's going to hit that 2. And then the actual value of f of x should actually be 1, right? So we have this 1, and so we should have a closed circle here. And that means that in order for it to be function, these have to be open circles. You can't have 3 points lined up vertically and fail the vertical line test. So this is in fact a function, and it satisfies everything they've asked for. It doesn't matter what it looks like at endpoints because they didn't say anything about it. From the left, it looks like we're going to approach -1. From the right, it looks like we're going to approach 2. And then we actually hit 1 for our f of x at 0. So we're going to have another question that's very similar to that. But this time there's going to be more restrictions, so we have to be a little bit more careful. So let's get our basic graph going. We have a big old graph right here. Plenty of space for us to work with. And so I like to kind of look at where are the points that matter to us. What are these values we care about? So for example, I see the x values are going to be this 3, again 3, a -2, and then 3 and -2. So our main values that we care about are going to be at x equals 3 and x equals -2. Those are our main portions we care about. So focusing on this x equals 3, right? So the limit as we approach 3 from the right, say we're coming up from over here, yeah, is going to have to equal 4. And so our 4 is going to be up here, and we're just going to slowly approach this 4, right? And then our limit as we approach 3 from the left is going to have to equal 2. Now I'm not going to start drawing over here because I don't want to mess up what's going on for this -2. So I'm going to start drawing kind of close to this 3, and I'm going to say, okay, well, I know I want to hit this 2, so I'm going to go maybe up like this, I'm going to approach that 2. Yeah. And then actually skipping this portion, because I want to focus on this 3. I want to get this kind of hammer this out, right, to find out what's going on with this. I know that the actual f of 3 should in fact equal 3. It should be an actual value of 3 right here. Yeah. So that means we need our open circle right here and our open circle right here. And so this 3 portion, we kind of did everything they asked for. We checked that, and we checked that. Next, we want to make sure we fill out this negative 2 properly, right? And so we know that the limit as it approaches negative 2 should look like it's going to hit 2, right? So once again, okay, let's approach 2. And maybe we'll go like this, and we'll approach 2 over here. And it looks like it's about to meet, but there's a tiny hole right there. And we know the actual value of negative 2 is going to be 1. And so we have a closed circle at 1 floating right below. And so we have this little discontinuity, we have this little weird gap, right? And we have fulfilled all the requirements. Notice, I don't really care what's going on at the endpoints, at the infinity and negative infinity and all that. I only care about what they told me specifically. They said specifically this thing about 3, right, as you approach from the right, as you approach from the left, and what you actually get. And similarly for this negative 2. And so that's all you need. So in terms of limits and graphs, you want to focus on, for these kinds of questions, you say, what did they give me? What points are important? Kind of mark them down, and then kind of focus on those portions. Don't try and draw everything at once. Just hone in on it 1 point at a time. So that's going to wrap it up for limits with graphs. There are a lot of other kinds of questions relating to the algebra of it. These would be really useful in terms of defining derivatives and what you do with those. But that's it for the graph. So I hope this was helpful, and thanks for watching.